right, so where we left off yesterday, we were talking about the Greeks and their contribution to our understanding of astronomy. Where we started guessing and started testing and knowing more is about the time of the Greek civilization, where we started really making advancements scientifically to understand and not just observe and guess. So we're going to actually start back with the Greeks where we left off. We're going to start with Ptolemy. Ptolemy was an ancient astronomer, more of a philosopher, really. Back in that time, we really didn't have the scientific tools that we have now. So it was all just based on observation and trying to generate a description or an explanation based off of just observations. So based on his observations, Ptolemy believed in what we call a geocentric universe. Geocentric, geo is Earth, centered. So the Earth the Earth is the center of the universe, and everything in the universe revolves around the Earth. So here you can see a picture of what Ptolemy would have thought the universe looks like. You've got the Earth in the center, the moon definitely goes around us, and then Mercury and Venus, the names there, Greek in origin, are between us and the sun. They were able to observe that occasionally Venus and Mercury would go between us and the sun, so that put them there. The sun would be fourth in line there, going around us, and then Mars, Jupiter, and Saturn, who ducked behind the sun at times during rotation, must have been 5, 6, and 7. And then beyond that, we couldn't see anything else with the naked eye. All those other planets just looked like stars, so beyond that, we weren't even able to see a dot of light, and so there was just infinite stars beyond those planets that wandered around in the sky. The name planet means wandering star. And if you've ever seen a planet at night, you can easily see Mars and Venus at night or early in the morning if you go and look out. Through time, the position of Mars and Venus wander all over the sky. They're not set like the constellations. So that's how they knew that these things were different. They must be something else beyond the stars that seem to be fixed in location. So we know now that we're not geocentric, but if you think back to the observations and that being the only thing that they had, he wasn't crazy, he just didn't know what we know today. That belief of a geocentric universe continued for many, many years, and even when we moved from Greek mythology into more of the rise of Christianity in Greek and Roman area, and that during that time period, Roman mythology kind of went by the wayside, Greek mythology, and you had the rise of Christianity and even Islamic faith. You still, in the Christian faith and the Islamic faith, you still had a divide between the heavens and the earth. In the beginning, God created the heavens and the earth. So the earth is a special place. We are taken care of by God. We were important to God. And then you had the heavens, everything else. So this is a famous picture from way back then. You've got God looking down over the earth. You can see there's the earth, and then on either side of God, there's the sun and the moon and some stars and everything else kind of focused around the earth. So this idea that we were geocentric, that we were special and set apart, was even backed up by the religious scholars of the time. Copernicus, however, when we get into the 1400s, the 1500s, he was Polish. He was an astronomer that noticed that things weren't lining up mathematically the way that they should if we were truly geocentric. So he proposed a different view based off of his calculations of how things were rotating. He believes the sun is at the center and everything else revolves around the sun. Now, this idea is more like what we know of today. Here's his picture down here. You've got the sun at the center, Mercury and Venus are between us and the sun, just like it was before, but we're third in line with our moon still going around us. And then Mars, Jupiter, and Saturn out beyond that. And you still could not see beyond that with the naked eye, so you had distant, motionless stars, things that weren't moving. So this heliocentric idea is more like we know today, but it didn't jive well with the powers that be. His views were rejected, and of course not having any kind of telescope and not having the deep math that was necessary to prove those theories, he kind of had to back off and say never mind. 50 years later, in the late early 1600s, then you had a guy named Galileo that was able to come in and prove the idea of that heliocentric universe that we now know. So Galileo Galilei, we've actually talked about before. Remember the dude dropping stuff off the Leaning Tower of Pisa? Same guy. He is known for patenting the first 10-time magnification telescope, and we say patented because about that time there were several people working on the idea. He just ran into office first, right? So he patented the telescope and was able to see more than we could have ever seen before. He found that the surface of the moon is cratered, which makes you wonder, cratered by what? What else is out there? And then he also found things that were orbiting around Jupiter, which we know to be 4 of the, what did we say the other day, 50 or so moons that orbit around Jupiter. Those 4 Galilean moons that they're called, Io, Cassiopeia, Europa, and Ganymede, those were important to proving the heliocentric universe, because if there were things rotating around something other than the Earth, then we weren't the center of the universe. It rotates around, or things like planets revolve around whatever has the most mass at that time that they're closest to. So this went a long way to helping him prove his point, as well as a little bit higher math. So telescope, better math, he was able to prove it and defend his idea. However, powers that be still didn't like it. That's kind of a theme in science. Powers that be were not a fan of his idea at first. It prompted an inquisition from the Catholic Church, which is kind of like the church version of being on trial. He didn't have a crime against the state, he had a crime against the church. And for that, he was sentenced to house arrest with his daughter in Florence. Now, during that time, he spent a lot of time writing a lot of his ideas down. And so a lot of the things that we know now from Galileo, we know because of the books and the journals that he penned while he was under house arrest. But then in 1992, yes, about 350 years after he passed away, he was eventually pardoned by the Catholic Church, the official Catholic Church, while the namesake spacecraft, the Galilean satellite, headed towards Jupiter to study those 4 moons that he discovered. So, kind of interesting. Better late than never, right? Sure. Then another guy that we've actually talked about before in class, Isaac Newton. This guy lived about 50 to 100 years after Galileo. We went from 3,000 years of Ptolemy's ideas to now 100, 150 years of picking up the pace here. Newton came up with 3 laws of motion, which we studied, right? He also created calculus, and the purpose of calculus was to study the planetary orbits. They're not perfect circles. They're more ellipsoidal. They have a closer side and a farther side. They're more egg-shaped. And so he needed something to help him calculate and predict the orbits of the planets. So that's what calculus was originally for. So Newton helped us launch even further with our understanding of astronomy. And then it just kind of snowballed from there. We went 3,000 years to like 150 years, and now it's getting super fast. Now that we can see further and we can understand more, then we discovered new planets like Uranus and Neptune, and then finally Pluto in 1930, which now Pluto's not a planet, but that's another thing. We were able to see that we're part of a galaxy called the Milky Way, and then we could estimate how big that Milky Way is. We could calculate the surface temperatures of stars and create that diagram that we were talking about. Oh my gosh, the star Hertzsprung-Russell. You know what I'm talking about? Where we're a G-class star. That diagram. Anyway. Able to calculate the temperatures based off of the electromagnetic radiation that we're receiving. Einstein came up with that theory of special relativity based on the speed of light and how that light travels in different frames of reference. We were able to find composition of stars, and we talked about that the other day when we talked about the sun. We understand a little bit more about nebulas. We know now that the universe is expanding, and that has to do with everything being redshifted, showing that everything's moving away from us. Remember Doppler effect. We figured out how the sun works with thermonuclear fusion. We're able to use more than just visible light for astronomy now. We can use radio astronomy and X-ray astronomy, infrared astronomy, gamma astronomy. We came up with the idea of the Big Bang theory, that everything started as nothing and then exploded from there, just like Genesis has told us a long time ago. First there was nothing, and then there was light, right? Took us a while, but we got back to that. And then we learned a lot more. Now, that's a whole bunch of lists. Like I said, there's so much out there about astronomy. If this has engaged your curiosity, please dig further and deeper into any of these subjects. There's so much to learn out there. I just kind of wanted to give you a brief overview, and this is a super fast overview. But next week, when we come back together, we're going to look at not just looking at the sky and trying to figure out what's going on up there, but actually going there and figuring out how to get to the heavens and how to leave the earth and discover more in person. So we'll talk about that, my favorite part, on Monday. Have a great weekend.